let's talk about slides and how they work. And here's a family mold. The plastic comes in from the barrel, and then this runner comes around and it drops it into each side of this part. And the part has these threads on it. So you can see the threads, and it's got to pull out this way, and then it's got to break apart in the side direction. So we use slides to do that. So if we come out a little bit, we can look at the mold and how this mold is designed. So here is the core. These are the cores that come in, and they core out the middle of this connector right here. And these things right here that are these pins right here, these are called core pins, and they pull the slide out. So when this mold cavity pulls away from the other half, it pulls the slide out. And this little piece back here is called a cam block, and so it's on both sides. And so as the tool starts closing, they line up with this same angle here, and then this holds it shut so the slides can't push apart. So if we come down into the side of the tool here, and we look at the slide, you can see are in an open position. So here are the holes where the cam pins go in, right there and there and there. And then here's that back cam block that holds the slide in. So when this comes back forward, it's going to close the slides, and the slides are going to go in towards the center of the tool. So that's how a slide works. And you can see that it's fairly complicated. So we've got to put water lines in here. These parts right here are called gibs, and they hold the slide in there. So this slide runs along this track right here. So this is pretty tricky tooling. And as you can see, when we add these slides to the tool, it gets real expensive, and it takes about 3 or 4 times longer. So you can count on a mold like this taking 16 to 24 to almost a year to build if it's a high precision tool. And then we have to maintain all this. So this gets into a maintenance issue where we're always having to pull these things apart and clean out all the dirt and the grease that gets in here. And so the best thing to do is to try to design a part that doesn't need slides. In a lot of instances you can't, but this is an example of a slide tool. Okay. Okay, so here's a part that's got some undercuts on the bottom. And again, if you spend time thinking through your design, you can save a lot of money. But this I pulled down from GrabCAD, and this is the underside. And you know, things like these sharp corners here, you have to burn this with an EDM. You can't cut that out. So always put radiuses all over everywhere. This is just a bad design that really could have cost a lot less and taken a lot less time to build. But here's where these lifters are. So here's an undercut that's on the inside of the part, and right here. So we have to pull away on the inside of the mold, and it gets really tricky. So I'm going to show you the mold design on this particular part and why it costs so much money, why it takes so long to make, and why it's a maintenance nightmare where there's always potential problems. So we're going to go into this tool right here, and if you look at this, our ejector system is down here, and we've got to be able to push with a bar, and it's going to go and lift out from this undercut here, and it's got to be able to travel along this flat edge as the ejection takes place, and this all wears, so it becomes a big problem. I'm going to go in and just hide a few things here so we can look at it a little bit closer. So I'm going to, let's see here. I'm gonna just show you this lifter without the section view on, and so he's got slides pulling in this direction out away from the part here, and then the lifters are underneath the part right here. So if we hide this part right here, you'll see like this is a lifter right here to pull this undercut right here, and then we've got the lifters over here that pull this undercut right here, and then the slide that pulls away in this direction. So this all has to be wire EDM'd out. So you can't cut this with a CNC mill, and you've got to run a thing around called a wire EDM, and then you got to make this part and fit it, and it just becomes a nightmare. So always try to think about these undercuts. You can make a mold that is like such a pain in the ass to keep running that it really just becomes you know, you might as well just redesign the part and do it right. So here's another lifter over here that lifts up in an angle along here. So if we come in and we cut a section view through here, so this tool I predict is probably not running any longer, and they probably redesigned it to go ahead and do it. Well, hold on here. We're going to turn this one off. They probably redesigned it to deal with these problems that were built into the part. So I'm going to create a section view here, and I'm just going to pull it through until we can find this lifter right here on the side. So here is this, whoops, this lifter, set of lifters here and here. And I bet this mold cost, oh Lord, $500,000 to make. And if the product designer designed it with an understanding of what's going on, they could have gotten this down to, you know, $100 grand or $50 grand. But that's not the case here. So what we want to do is we want to keep that all in mind when we're designing our plastic parts. And again, let's just look at the part real quick. But you've got this undercut here, you've got this undercut here, this one here, and you've got these clips right here, these holes right here that have to pull this way because the mold is designed to open. The parting line is right here. So this is where the mold's going to split right here, but it does not split where there's an undercut. You got to pull this whole wall here, and you can't get the part out because of these undercuts here because the steel has to move away. So it just becomes a big pain in the ass. All right, there you go.